So we'll start off with the questions given in your textbook. The grade 11, unit 4, exercise 4.1. I'm sure you have already answered these questions and now you're going to confirm your answers with my discussion. Group of children studied the spreading water waves generated in a pond with still water by throwing stones onto the water surface. What happens to the energy of the waves? Suppose you place a paper boat on the water surface and disturb the water surface a small distance away from the boat. What change would you observe in the paper boat? What does it illustrate? Next one, sketch a diagram to show what happens to the water surface. Which type of mechanical waves do water waves belong to? In what way do the above waves differ from the sound waves traveling in air? So, these are what you have to answer for the first question. I will start with the first part. Group of children studied the spreading water waves generated in a pond with still water by throwing stones onto the water surface. So, this is how we started the lesson. We observed what happens to the surface of water, how waves are formed and propagated through the surface when you throw a stone into water or when you put a pebble into water. So, here they generate water waves by throwing stones onto the water surface. What happens to the energy of the waves? So, you can remember, students, as the stone falls on the surface, a disturbance is generated and that propagates in the form of a wave. It goes in cycles. If you look at the surface of the water, you can see as round rings or circular rings. That's the wave spreading in all different directions. And you know, when waves propagate, kinetic energy due to the vibration or the movement of particles of the medium, kinetic energy is transmitted along with the wave. So, what happens to the energy of the waves? It gets transmitted with the wave. We have to write the answer as energy is transmitted when wave propagates. So, that is what happens to the energy. Next one. Suppose you place a paper boat on the water surface and disturb the water surface a small distance away from the boat. What change would you observe in the paper boat? What does it illustrate? Say, if this is the surface of water, there is a small paper boat like this. Somewhere here we generate a disturbance. What do you see? You can see that the paper boat moves up and down because the water surface moves up and down. But the paper boat does not move sideways. It doesn't go along with the wave. So, that illustrates the particles of water, that is the particles of the medium, only moves up and down. They do not move along with the propagation of the wave. So, here suppose you place a paper boat on the water surface and disturb the water surface a small distance away from the boat. What change would you observe in the paper boat? That's the first question. So, what change do you observe? paper boat moves up and down on the surface of water. Right. So, what does it illustrate? So, it illustrates that the particles of medium do not move with the propagation of the wave. So, we can say it illustrates that the particles of the medium do not travel with the wave. They only vibrate, or you can say oscillate. So, that is the conclusion or what the observation illustrates. With that, I will move on to the next question. Sketch a diagram to show what happens to the water surface. So, here initially the water surface is still surface. You put a stone is thrown onto it, then initially there will be a disturbance. If you look from the top, if this is the point where the stone fell, you can see the water ripples like this going around in circles. So, in all directions you can see the ripples on water surface. That will propagate in all directions. So, it will be in all directions, but when you look at the waveform from the surface, or I will just show only the waveform, you can see, let's say if this is the from the top view, you can see the ripples this way, and if you look at the surface of water, you can see that it moves in a manner like that. And also closer to the disturbance, this part will be higher, the amplitude of the wave will be higher. And when you go away from the disturbance, the amplitude will decrease. So, that is also visible. So, you see a wave propagating through the surface of water. That is to show what happens to the water surface. The next question, which type of mechanical waves do water waves belong to? Now, we saw that they need a medium. So, I am sure you know the type. They are mechanical waves, and under mechanical waves, the direction of particle movement is 1 and the wave propagation is perpendicular to that. So, therefore, they are transverse waves. So, which type of mechanical waves do water waves belong to? We can say transverse waves. The next one. In what way do the above waves differ from the sound waves travelling in air? What are sound waves travelling in air? They are longitudinal waves. These are transverse waves. So, how do they differ? Here the direction of particle movement and the direction of the wave are perpendicular. But in sound waves traveling through air, the direction of particle movement and the direction of the wave are parallel. So that is how the two waves differ from each other. If I write the answer, you can say in water waves, the direction of particle movement and the direction of the wave are perpendicular. But in sound waves traveling through air, they are parallel. So that is how they differ. In this, the direction of particle movement and the direction of the wave are perpendicular at 90 degrees angle. Whereas in sound waves, both are parallel. That is why this is a transverse wave and sound waves are longitudinal waves. The next question. The end B of the metal blade AB shown below is clamped to a table. So here B is clamped or fixed to the table. It is made to vibrate by a force applied to the end A. So we make it to vibrate by pushing it or applying a force to the end A. Give a rough sketch to illustrate one vibration generated in the blade. Use letters C and D to show the maximum displacement. Describe what is meant by the amplitude using the points marked as A, C and D. If 50 vibrations take place during 5 seconds, find the frequency of the vibrations of the metal blade. Vibrations of the metal blade gives rise to compressions and rarefactions in air. To what physical quantity related to sound waves in air is the distance between two consecutive compressions equal to? What is the sound characteristic that depends on the frequency? What is the sound characteristic that depends on the amplitude? The same musical note was played with several musical instruments. Each one could be identified separately. What characteristic of sound does this depend on? So these are the questions. I will answer them one by one. The NB of the metal blade AB shown below is clamped to a table. So here you can see it's clamped to the table. It is made to vibrate by a force applied to the end A. Give a rough sketch to illustrate one vibration generated in the blade. Use the letters C and D to show the maximum displacement. So let's say we give a push from this side. So what will happen? First the blade will move this way. B will be fixed to the table. The metal blade will move to one side. Since we are pushing it that way, it will go there, come to the same point, but it will move towards the other side. And there also you will see the displacement. If it's here, going that way, coming this way, both the displacements will be the same. So start at A, go to that point, let's say that is to denote as C, come back to A and again to D and come back to A will be one full cycle. That is one full vibration. We have to sketch that here. Now here I will mark this as A and B. The NB, you all know, the NB will not move, only NA will vibrate. So then, in order to show the movement, I will use broken lines. So initially, it will go to a point somewhere here from A to C and then back to A, and finally, it will come to a point D. These two should be equal. So it's almost equal. I didn't take a measurement, but you can see these are almost the same value. So here from A, they have told us to mark C and D. And these two, the displacements or the distances between A to C and A to D, or these angles have to be equal when it really happens. So then if we show the way the vibration takes place, it goes from A to C, then from C again it comes back to A, then to D, and finally it comes to A. That is one full vibration or one full oscillation. Starting, vibrating and coming back to the same point. So that will correspond to one wave. That is what they have shown us here. Use the letters C and D to show the maximum displacement. So here, this is one maximum displacement. This is the other maximum displacement. With that, I will move on to the next one. Describe what is meant by the amplitude using the points marked as A, C and D. So there, if we consider the points marked as A, C and D, you can remember A was here, then when the blade came to point C and the blade comes to point D, and the two displacements have to be equal. If we denote this as a wave, at this point, it's point A, it comes to point C here, this maximum displacement, again to point A, and finally to point D, and then comes back to A. That is how it vibrates. Goes in this direction, comes back, goes here and comes back. So A to C, C to A to D and back to A to C. So A to C, this displacement is the maximum displacement towards this side. And A to D, from here to here, is the maximum displacement towards the other side. So those two displacements are equal to the amplitude of the wave. So describe what is meant by the amplitude using the points marked as A, C and D. So according to the diagram, if you write down C and D are the maximum displacement of the blade. So if we take the magnitudes of these two, you all know displacement has direction. But here we consider the magnitude. The magnitude of C is equal to D, and that is equal to amplitude. So this is the amplitude here and also here. That is a physical quantity of the wave. With that, I will move on to the next question. If 50 vibrations take place during 5 seconds, find the frequency of vibrations of the metal blade. What is frequency? Number of vibrations in a unit time. So to find frequency, what do we need to do? Divide the number of vibrations by the time taken. So here frequency F is equal to 50 vibrations divided by 5 seconds. That is equal to 10 per second. What is this unit equal to? Hertz. That is the standard unit of frequency. So 50 divided by 5, 10. The frequency is 10 Hertz. Vibrations of the metal blade gives rise to compressions and rarefactions in air. To what physical quantity related to sound waves in air is the distance between two consecutive compressions equal to? So here you have to look at these terms. Two consecutive compressions. So compressions are similar states and they are consecutive. So that means that will be equal to the wavelength of the wave. So here the answer will be wavelength. With that, I will move on to the next question. What is the sound characteristic that depends on the frequency? What are the three characteristics? Pitch, loudness, and quality of sound. What depends on frequency? The pitch. So here it is the pitch. What is the sound characteristic that depends on the amplitude? What is that characteristic? It is the loudness. So here it is the loudness. The same musical note was played with several musical instruments. Each one could be identified separately. What characteristic of sound does this depend on? So out of the three characteristics, what is it? The quality of sound. So here the answer will be quality of sound. Then I will move on to the next question. Electromagnetic waves do not need a medium for propagation. That you know very well. Write down three characteristics of electromagnetic waves. You all know the three characteristics. The electromagnetic wave, it's made up of an electric medium and a magnetic medium which are perpendicular to each other. So therefore, the wave is not affected by external electric or magnetic medium. That is the first characteristic. They are not affected by external electric or magnetic fields. What is the second characteristic? Why do we call them electromagnetic waves? Because they don't need a medium for propagation. And that is the second characteristic. They do not need a medium for propagation. Then there is the third characteristic. What is that? What is the speed of electromagnetic waves in vacuum? 3 into 10 to the power of 8 meters per second. So that is the third property or characteristic of electromagnetic wave. They travel with a speed of 3 into 10 to the power of 8 meters per second in vacuum. You have to mention it as vacuum. Why? Because when these waves enter into a medium, their speed changes. Actually, their speed decreases a little bit. But in vacuum, the speed is 3 into 10 to the power of 8 meters per second. So, those three are the characteristics of electromagnetic waves. The next question. What is the angle between the electric field and magnetic field generated together in an electromagnetic wave? What are these waves similar to? They are similar to they are a type of transverse waves. Why? The two medium and the direction of the wave are perpendicular to each other. When we say perpendicular, what is the angle? If this is the electric field, this will be the magnetic field. So, the angle will be 90 degrees. So, what is the angle? So, we have to write the answer as 90 degrees between the electric field and magnetic field generated together in an electromagnetic wave. The next one. What is the angle between these two fields and the direction of propagation of the electromagnetic wave? So, already I gave you all the answer. These two are perpendicular to each other, and with that, if these two are the fields, they move in a direction perpendicular to that. So, here again, angle between the two fields and the direction of the wave, that is again 90 degrees, or you can even say right angle. I will move on to the next question. The figure below shows a segment of a string along which a transverse wave is propagating. So, you can see the transverse wave there. What physical quantity of a wave is the distance between the points D and E equal to? So, here this is D and this is point E. You can see the 2 points there. They are in similar state of motion and they are adjacent to each other. So, what is that distance equal to? It is the wavelength lambda. So, from here to here, it is the lambda. So, here we have to write the physical quantity. We can say wavelength. If you want, in brackets, you can write it as lambda also. That is the symbol for wavelength. The same distance above is shown by the distance between two other points in the figure. What are these two letters? Now, if you take the other letters A, B and C, from A to B, that is only half of the way. So, they are not in the same state of motion. If you take A and C, yes, because from here particles are going to move upwards. From point C also particles are moving upwards. But from point B particles are moving downwards. So, A and B, the state of motion is different. A and C, the state of motion are same. So, therefore, the distance between points A and C is also equal to wavelength lambda. So, what are these two letters? You have to write A and C. I will move on to the next question. There are many musical instruments in the music room of your school. Name 2 string instruments, 2 percussion instruments, 2 wind instruments that you expect to find in the music room. Write down 2 factors on which the frequency of the sound generated by a string instrument depends on. Write down 2 factors on which the frequency of the sound generated by a wind instrument depends on. Write down 2 factors on which the frequency of the sound generated by a percussion instrument depends on. So, there are these questions. We will answer them one by one. There are many musical instruments in the music room of your school. I am sure most of you all play different types of music instruments, and also there are many instruments used for the bands and for music as a subject as well. Name 2 string instruments. You can name many instruments. Out of those, the ones you commonly find in school, we can consider violin and even a guitar can be found in school. So, for string instruments, A, I will write the instruments as violin and guitar. What are the other instruments? Even a sitar, a veena, all these are string instruments. 2 percussion instruments. What are percussion instruments? They need to have a membrane or a metal surface for vibration. If you think of instruments that have a membrane for vibration, you can think about many different instruments. The tabla, the drums, or even the rabana, all these have a membrane. So, I will write one instrument. I will write the drum and an instrument that has a metal surface. You can think of the cymbal or the thalam or thalama. Those all xylophone. All those have a vibrating metal surface. So, here I will take the cymbal. So, both these are percussion instruments. Then the next one, 2 wind instruments. Again, you know many examples. You can think of the flute, the recorder, the trumpet. Any one of those instruments is available in the school. So, here I will write the examples as flute and trumpet. So, those 2 are examples of wind instruments that you would expect to find in the music room. I will move on to the next one. Write down 2 factors on which the frequency of the sound generated by a string instrument depends on. You all know there are three factors. One is the length of the string, the other one is the tension of the string, and the third one is the mass per unit length of the string. So you can write down any two factors. So I will write down the factors as length of string and the tension of the string. Write down two factors on which the frequency of the sound generated by a wind instrument depends on. In this question, students, although they say two factors, you all know there is only one factor that affects the pitch or the frequency of the sound generated by wind instrument. So, instead of two, I will write only one factor. What is that factor? The length of the vibrating air column. So, here it is only the length of the vibrating air column. That is the factor on which frequency of the sound depends on. The last one. Write down two factors on which the frequency of the sound generated by a percussion instrument depends on. You all know how sound is produced by percussion instruments. Either by the vibration of a membrane or a metal plate or rod. So, what does the frequency depend on? It depends on the tension of the membrane or the metal plate and the surface area of the membrane or the metal plate. So, here they want us to write two factors again. Then I can say tension of the membrane, or it depends on the surface area of the membrane or the metal plate or rod. So, those are the two factors on which the frequency of sound generated by a percussion instrument depends on. With that, I will move on to the next question. Explain the following scientifically. The first one. When a ringing bell is held by hand, it stops ringing. How does the bell produce sound? Due to the vibration. When a structure hits on the metal rod or the metal structure, due to that vibration, sound is generated. And when you hold the bell, what happens? The vibration stops. So, then there will be no sound produced. That is what you have to write here. When held by hand, the vibration of the bell stops. Therefore, sound is not produced. So that is the scientific explanation here. The pitch of a flute when played while the holes are opened one by one becomes different from the pitch when all holes are closed. So what happens here? You have all the holes closed, you open them one by one. The length of the air column or the length of the vibrating air column changes. So when the length of vibrating air column changes, the frequency of the sound changes. So that is why you hear different pitch of sound. Why? The pitch depends on frequency. So here we have to say when all the holes are closed and opened one by one, the length of the vibrating air column changes. Therefore, the frequency changes and thus the pitch of sound. So the pitch depends on frequency. Frequency depends on the length of vibrating air column. The next one. Although the lightning and thunder both happen at the same time, there is a delay between seeing the light and hearing the sound of thunder. What happens first? You see the light first, then only you hear the sound of thunder. Why? Because of the different speeds of light and sound in air. Normally in vacuum, the speed of light is 3 into 10 to the power of 8 meters per second. What is the speed of sound? It does not travel through vacuum, but in air the speed of sound is 330 meters per second if it is 0 degrees Celsius and it is dry air. So if you compare the values 3 into 10 to the power of 8 and 330, the speed of light is very, very high. So therefore light travels fast. So that is what you have to write here. Speed of light in vacuum is 3 into 10 to the power of 8 meters per second. Speed of sound in dry air at, we'll say 30 degrees Celsius is 350 meters per second. So you know when temperature increases, speed of sound increases. But still 350 and 3 into 10 to the power of 8. So speed of light is much higher than the speed of sound. Therefore, thunder is heard after the lightning is seen. So here in this answer, since we are explaining it scientifically, the most important part is where you explain the speed. You have to say speed of light is very much greater than speed of sound. So with that, students, the questions in your textbooks have been discussed. Now for practice, I will discuss some more additional questions with you. Extra question 1. Underline the correct answer. Select the incorrect statement regarding waves. So always, students, when you read questions, you have to note whether they are asking for the correct statement or the incorrect statement. Here the incorrect statement. A disturbance propagating through a medium or space is known as wave. That is correct. That's the definition or explanation of a wave. Energy is transmitted in the form of waves. That is also correct. When energy is transmitted, particles of the medium travel along with it. That is incorrect. Why? The particles of the medium only vibrate. Only the wave propagates carrying energy along with it. Particles of the medium only vibrate and do not travel along with the wave. So that is also correct. Then the incorrect statement is the third one. Second question. A wave that requires a medium to travel is. You all know only the mechanical waves need a medium for propagation. Electromagnetic waves do not need a medium for propagation. Visible light rays, they are electromagnetic. Electromagnetic waves don't need a medium. Radio waves, again, they are part of the electromagnetic spectrum. So the first three are all electromagnetic waves. Mechanical waves, they need a medium for propagation. So a wave that requires a medium to travel is mechanical waves. The next one, select the correct statement from below. In transverse waves, the direction of propagation of the wave is perpendicular to the movement of particle. That is correct. That is the correct statement, but we will go through the other three answers as well. In longitudinal waves, the direction of transmission of energy and the movement of the particles of the medium are not the same. That is wrong. Why? Both are parallel to each other. So it's in the same direction. In longitudinal waves, the particles of the medium travel parallel to the direction of the wave propagation. Here it says particles of the medium travel. In mechanical waves, that is longitudinal waves, the particle does not travel. So because of that, this is also wrong. In transverse waves, the particles of the medium travel perpendicular to the direction of wave propagation. In transverse waves, the particles of the medium travel perpendicular to the direction of the wave propagation. Again here it says particles of the medium travels. So that doesn't happen in any of the mechanical waves, longitudinal nor the transverse waves. So here the correct statement is, in transverse waves, the direction of propagation of the wave is perpendicular to the movement of particles. So that is the correct answer, the first one. Okay. Then I will move on to the second question or the fourth question, second one in the slide. Consider the statements given below. A medium is not required for the propagation of the wave. B, they are not affected by electric or magnetic fields. Velocity in vacuum is 3 into 10 to the power of 8 meters per second. When you read all these three statements, A, B and C, you know what they are referring to. We'll look at the question. Correct statements regarding electromagnetic waves. There are three properties for electromagnetic waves. A medium is not required for the propagation. Correct. They are not affected by electric or magnetic fields. Correct. And the velocity in vacuum is 3 into 10 to the power of 8 meters per second. That is also correct. So there, if you look at the answers, A only, A and B only, B and C only, all are correct. Here, all the statements are correct regarding electromagnetic waves. With that, I'll move on to the next question. In which of the media given below does sound travel faster? Now you know sound doesn't travel through space or vacuum, but it can travel through all three states of matter: solid, liquid and gases or air. And it travels faster through solid, through air, through copper wire, through water, through vacuum. So it can travel through the first three, and out of those, copper wire is the solid. So sound travels faster through copper wire. With that, I will move on to the next one. Extra question 2. What is a wave? What is a wave? The propagation of a disturbance through a medium or space is known as a wave. That is what you have to write here. Propagation of disturbance through a medium or space is known as a wave. So students, when writing the answer, you have to give the important point. In order to complete the proper sentence, you can write it as is known as a wave. But this is the part that is very important for the question. What are mechanical waves? What are mechanical waves? Waves that need a medium for propagation. So here, waves that need a medium for propagation. Write 2 examples of mechanical waves. Again here, look at the question. Immediately when they say 2, you might think of the 2 types. Here they have asked for 2 examples. So it can be any example. Can you think of some examples? The waves generated on surface of water, wave when you move a thread, or the sound waves that travel through air. All these are mechanical waves. Or vibration of a string that generates the wave. That is also a mechanical wave. So here write 2 examples of mechanical waves. I will write waves on the surface of water and sound waves traveling through air. You can even write it as sound waves because sound only travels through a medium. Therefore, it is an example for mechanical waves. Write the 2 types of mechanical waves. So, this is what I told you. Based on the direction of motion of the particles of the medium and the direction of propagation of wave. Here you don't have to explain, they only want you to write the 2 types. What are the types? The transverse wave, where the direction of motion of particle of the medium and the direction of the wave are perpendicular. And in a longitudinal wave, these 2 are parallel. So here we only need to write the 2 types. Transverse waves and longitudinal waves. So those are the 2 types of mechanical waves. The next one, extra question 3. A slinky with a few pieces of ribbon attached in certain places is shown below. So here you can see the slinky. You can remember the activity that we did in the lab. Okay. So these are the pieces of ribbons, the slinky, and they have shown the direction of the wave, and you can see how the slinky is vibrated. What is the relationship between the movement of the ribbons and the direction of the waves? The ribbons move in this direction, the wave moves in that direction. Those 2 directions are perpendicular to each other. So they have asked what is the relationship. You can write they are perpendicular. So here they are perpendicular. What is the name of the wave shown above? You all know when the directions are perpendicular, those are transverse waves. Transverse waves. The last one. What type of waves are water waves? Why does it come under this type? What type of waves? They are also transverse waves, or we can say they are mechanical waves. Why they are transverse waves? Because the direction of particle movement, that is how the water particles move, is perpendicular to the wave motion or the direction of the wave. That is why we call it a transverse wave. It is a mechanical wave. Why? It's water waves. So, water is a medium. A wave that propagates through a medium or a wave that needs a medium for propagation is a mechanical wave. So here they have asked what types of waves are water waves. Why does it come under this type? So for this I can write the answer as they are transverse mechanical waves. I'll include both the terms here. And why? Because they need a medium for propagation and the direction of movement of water particles. Here I will refer to it as water particles because it's the water waves. Particles is perpendicular to the direction of the wave. So that covers both the explanations. Why it is a mechanical wave and why we call it a transverse wave. So I'll move on to the next one. Extra question 4. So from the question you can see we are supposed to fill in the blanks. Sound waves are generated by what? Oscillation or vibration of particles of the medium. So sound waves are generated by vibration of particles. The acoustic energy produces a blank sensation. Acoustic energy is the energy that is transmitted by sound waves and they produce a sensation in your ear. What is that sensation? It is the hearing sensation. So the acoustic energy produces a hearing sensation. Third one, sound travels faster in dry air when the atmospheric temperature is high or low. When the atmospheric temperature is high. So sound travels faster in dry air when the atmospheric temperature is high. Fourth one. So visible light falls in the region of blank hertz to again hertz. So if it is hertz, it is the frequency. You have to know the frequency range of visible light. It is 4.28 into 10 to the power of 14 hertz to 7.69 into 10 to the power of 14 hertz. At least students, if you remember the values as 4 and 7.69 or almost 8, that is the region. 400 nanometers to around 770 nanometers. So that is the region of the wavelength, but here they have asked for the frequency. 4.28 into 10 to the power of 14 hertz to 7.69 into 10 to the power of 14 hertz. the rays used to take heat photographs. We all know we use one of the regions in the electromagnetic spectrum. What is that region? The IR rays. Infrared radiation is also referred to as heat radiation. So, heat photographs are taken using infrared rays. The rays used to take heat photographs are infrared rays. Red rays, or you can even write it as IR rays. Sixth one. Blank are used to photograph the bones present in different parts of a person's body. What are the rays used to take photographs of the bones? The X-rays. So, here we have to write the answer as X-rays are used to photograph the bones present in different parts of a person's body. The next one, sound is generated by people by the vibration of, how does sound generate? Vibration of vocal cords. So, here vibration of vocal cord. Electromagnetic spectrum is the range of blank identified by the different characteristics of those waves. How do we find the ranges? The frequency ranges. So, electromagnetic spectrum is the range of frequencies identified by the different characteristics of those waves. The distance between one particle and the closest next particle taking part in the wave motion having the same state of dash is known as the wave. They have motion having the same state of motion known as the wavelength of the wave. So, here same state of motion or movement is known as the wavelength. Here this refers to the wave motion, that is the movement of the wave. Here the same state of motion of the particles which are next to each other, that is the wavelength. The time taken by a particle for a complete oscillation is known as the period. That is the time taken by a particle for a complete oscillation is known as the period of that wave. So, with that we have finished these questions. The next one, extra question 5. Label the physical quantities of the wave shown in the diagram below. So, here they have given different physical quantities. What is A? You can see it is the maximum displacement shown by the particles of the medium. And what do we call it? It is the amplitude of the wave. So, A is amplitude. Then we have B. You can see these 2 points, the particles are at the same state of motion and they are adjacent to each other. So, what is that quantity? It is the wavelength. So, B is wavelength. And what is C? The upward movement is known as the crest, and this downward maximum distance travelled by a particle is the trough. So, C is a trough. So, those are the physical quantities shown here, and again we have D. If the maximum displacement is downwards, we call it a trough, and if it is upwards, we call it the crest. So here D is the crest. They are both similar but in opposite directions. The next one, extra question 6. The echo was heard 8 seconds after firing the gunshot. The speed of sound in air is 330 meters per second. Calculate the distance between the obstacle and the position from where the gun was fired. So here they hear the echo. So if the shot is fired from this position and the person listening is also somewhere here, you have the obstacle there. Sound travels this way and it has to come back. And if this distance is D, distance between the person and the obstacle is D, the sound travels 2D distance. So what is the equation we have to use? We use speed equals distance over time. What is the speed? 330 meters per second. What is the distance? That is what we have to find. Distance is D, but the sound travels a distance of 2D. So it has to be 2D there, and the time taken is 8 seconds. If we rearrange, D distance is equal to 330 into 8 divided by 2. That will be in meters. If we simplify the values, 2 and 8, 4. If I multiply the value, 1320 meters. That is the distance between the person and the obstacle, or the place from where the gun was fired and the obstacle. As I told you all students, if you don't substitute as 2D, you will get the distance from here to there and back to the initial point. So there you have to divide it by 2. Otherwise, it's always better to substitute with 2 there. This is distance D, and the distance traveled by the sound is 2D. Then you get the answer directly. With that, I will move on to the next question. Use a diagram to illustrate the waveform that transmits through air when sound generated by the vibration of a tuning fork travels through air. So here you can see tuning fork generates a sound, and to differentiate the sound and relate it to the instrument that produces the sound, what is the characteristic used? That is the quality of sound. Quality of sound is the waveform of the sound. So a tuning fork produces a sinusoidal wave. So what is the waveform? If we show it here, it will be like this. This is the waveform produced by a tuning fork. Use a diagram to illustrate the waveform that transmits through air when sound generated by the vibration of a tuning fork travels through air. They only want you to show the waveform. So we don't have to label any physical quantities here. The next one, extra question 8. What is meant by hearing range? What is hearing range? The frequency range of sound that can be heard by a person or an animal. That is what we call as hearing range. So, the frequency range of sound that can be heard by a person or an animal. That is the hearing range. Explain briefly how bats and dolphins use sound waves. How do bats use sound waves? They use ultrasound for navigation purposes, to fly around avoiding obstacles. And how do dolphins use ultrasound? To communicate among each other, to identify their prey, and to escape from large sharks or from their predators. So here explain how bats and dolphins use sound waves. You have to give the answer for both animals. Bats use it to avoid obstacles when flying in the night. Dolphins use it to communicate to identify the position of their prey and to avoid sharks. So they use it for 3 different purposes. What are the uses of ultrasound to men? We have discussed many different uses. So I am sure you can write down, or you have already written down all the uses. What are the uses of ultrasound to man? We can say determine the depth of the sea. Then we have the ultrasound scan. Then we have the use of ultrasound in crushing stones in the bladder, to crush stones in the bladder. Another usage is that ultrasound is used to solder metals. Soldering of metals. So in addition to these, we have discussed few more applications or uses of ultrasound. You can remember the ultrasound traveling through a solid does not travel further when there is an air gap. So that principle is used to identify air gaps and fractures in solid components of airplanes. So that is also another application. To identify gaps and fractures in solid components of an airplane. Another one. It is used in spectacles worn by blind people. So they use the ultrasound. So spectacles worn by blind people. So these are special type of spectacles. So these are the uses of ultrasound to man. So since they have asked what are the uses, I have written down all the uses. If they ask you to write 2 or 3, you can give any of these uses. With that, I will move on to the next question. Extra question 9. If the time taken by ultrasound waves transmitted by a ship to reach the detector again after reflection from the sea bottom is 6 seconds. Find the distance between the ship and the bottom of the sea. Assume that the speed of sound in water is 1440 meters per second. So here you already know if this is the surface of water, the ship is here, down sound waves go down and they get reflected by the seabed, and that is the distance or the depth of the sea. So here we have to use the equation for speed. Speed equals distance divided by time. The speed is given to you as 1440 meters per second. And distance, do you write d? No, you have to write it as 2d. Why? The sound travels once here and then goes back to the detector. So travels 2d distance and the time taken is given to you as 6 seconds. If we rearrange the equation, d will be equal to 1440 into 6 divided by 2. That will be in meters. So if I simplify 2 and 6, 3. So when we multiply that, you will get the answer as 13 and 4. 4320 meters. So that is the depth of the sea there. Okay, with that I will move on to the next question. Extra question 10. There are two main types of waves. What are they? What are the two main types? Mechanical waves that need a medium for propagation and electromagnetic waves that do not need a medium for propagation. So here you only need to write the two main types of waves. So we can say mechanical waves and electromagnetic waves. The two main types of waves. Frequency is a feature of sound. What is meant by frequency? The number of vibration in a unit time. So here if we write the answer, what is meant by frequency? Number of vibrations in a unit time. That is frequency. Plot the variation of displacement of a single particle with time to illustrate the motion of a wave. Denote the crest and trough. So, if we draw a variation. So, here if I plot the graph, you have to have this axis, another axis here. So, here they want you to draw the displacement with time. So, this axis is going to be displacement. And here this is the time of a single particle with time to illustrate the motion of a wave. So, there you will get a wave like this. I am drawing the graph. These have to be the same. So, when you all are drawing, if you draw according to a proper measurement, make sure that these are the amplitudes. They have to be equal. So, here we only need to denote the crest and the trough. Crest and the trough. So, that is the displacement of a particle with time. That is one wave. From this point up to here is one wave. The next question. Extra question 11. We hear the thunder sometime after we see the lightning. Why? We have discussed this question before. Why? Because the speed of light is greater than the speed of sound, even if it is in air. So, we see the lightning first and then we see the thunder. So, that is what you have to write here. Speed of light is greater than the speed of sound. Therefore, we hear the thunder sometime after we see the lightning. So, that is what you have to write. The important point is that you have to say the speed of light is greater than the speed of sound. So, you all know in vacuum, the speed of light is 3 into 10 to the power of 8 meters per second. In air, it's slightly lesser, but speed of sound in air is 330 to 350 meters per second, depending on the temperature. So, anyway, the speed of sound is very much less than the speed of light. The next one. What property of the wave affects the loudness of the sound? You all know there are different properties of physical quantities for waves, and one of those affects the loudness. What is it? It's the amplitude. So, here we can directly write the answer as amplitude. Write the frequency range of ultrasound and infrasound waves. So you all know there is a hearing range. What is the hearing range? 20 Hz to 20,000 Hz. So then what is ultrasound? Ultrasound is the sound that is above 20,000 Hz. So more than 20,000 Hz is ultrasound. And what is infrasound? Less than 20 Hz. So less than 20 Hz is infrasound. So those are the frequency range of the two different sounds, ultrasound and infrasound. I'll move on to the next one. Extra question 12. Write 2 applications of ultrasound in the field of medicine. I am sure students you know the answer. We have discussed many applications of ultrasound. Out of those, they want you to write the applications in the field of medicine. What are the applications? One is the ultrasound scanning, used to observe the function of the heart or the development of a fetus inside the mother's womb. So basically you can say ultrasound scanning. What is the other one? To crush stones in the bladder. So we can write those 2 applications here. Ultrasound scanning and to crush stones in the bladder. So those are 2 applications in the field of medicine. Then write 2 examples each for string instruments, percussion instruments and wind instruments. So you know the examples. For string instruments, we can write the sitar, violin or even guitar, veena, any 2 of the string instruments. Then percussion instruments. Percussion instruments. What are the percussion instruments? We have seen many types of drums or the instruments that use membranes. The rabana, tabla, the different type of drums, all those use membranes. And instruments like the cymbal and the xylophone, they use a metal surface for production of sound, a metal rod or a metal plate. So you can write any 2 of those instruments here. I will say the drum and the xylophone. And also wind instruments. Again, wind instruments, there are many different wind instruments. You can write the flute, clarinet, trumpet, recorder, any 2 of the instruments. So, wind instruments, I will write as flute and trumpet. But you all can write any instrument that you like as long as it's relevant to the correct type. The next question. How is ultrasound used to determine the depth of the sea? You know the procedure. It's called the sonar detection. So here you have the surface of water, the ship is here, sound ray is produced from the ship and sent into water. It gets reflected by the surface of the sea or the seabed, and when it reaches the ship again, the detector can determine the time taken for the sound to come back. So from that we can calculate the distance or the depth of the sea. So how is ultrasound used to determine the depth of the sea? So if we write the answer, ultrasound waves. Waves generated from the ship gets reflected by the bottom of the sea. The detector in the ship can detect and determine the time taken for the waves to come back. Then using the time and speed of sound in sea water, distance is calculated. So this is the calculation that we have done before. The detector can detect the time taken, and we know the speed of sound in seawater. Using the two values, you can calculate the depth of the sea. With that, I'll move on to the next one. Extra question 13. What is meant by hearing range? What is the hearing range of man? What is hearing range? The frequency of sound that can be heard by man or an animal. And the hearing range of man, 20 Hz to 20,000 Hz. So first we have to say what is meant by hearing range. The frequency of sound that can be heard by an animal or man is known as hearing range. Then the second question, hearing range of man. Man is 20 Hz to 20,000 Hz. So that is what you have to write here. When the same notes are played by different instruments at the same pitch, we can recognize the sound of each instrument. What property of sound makes them different? What is the property that helps us to identify the sound from different instruments? That is the quality of sound. So here the property is quality of sound. Then the next question, extra question 14. The frequency of a sound wave is 170 Hz. The wavelength is 2 meters. Calculate the speed of this sound wave in air. I am sure you can remember the equation. What is speed? Speed is equal to frequency into wavelength. That is V equals F lambda. So that is the equation that we have to use here. They want us to calculate the speed of these sound waves. So speed equals F lambda. What is F? Frequency 170 Hz. And what is the wavelength? 2 meters. So when you find the value, it will be equal to 340 Hertz is per second and you have meters. So meter per second. That is the speed of sound. The distance between two crests of a sound wave traveling through water is 2 meters. There are 3 waves generated in a second. Calculate the speed of the sound wave in water. So another calculation. Here, if you take the sound waves, if you take 2 crests, this point and this point, here and here, what is this distance? That is the lambda. So here they say it is 2 meters. So that means the wavelength of the wave is 2 meters and there are 3 waves generated in a second. That means lambda equals 2 meters and the frequency is equal to 3 per second or 3 Hertz. So we need to calculate the speed of sound in water. Speed of sound in water. What is that? Again the same equation, F lambda. If we substitute, frequency is 3 and wavelength is 2. So that is going to be 6 meters per second. Then the next question. Extra question 15. What is a sound source? What is a sound source? A source or a substance that can generate sound. So that is what we need to write here. A source that produces sound. It can be a musical instrument, it can be the vocal cords, or it can be any other material like a tuning fork that can produce sound waves. What is a string instrument? Write 2 examples. What is a string instrument? A musical instrument in which sound is produced by the vibration of strings. And we can write examples. So if I write the answer here, musical instruments in which sound is produced by the vibration of strings. And write 2 examples. We have discussed many different examples. You can write any 2. We can write the example as guitar and a sitar or a veena. So here, this is the answer for the first part. And the second one, we can say a guitar and a veena. So with that, I'll move on to the next question. Extra question 16. What is a wind instrument? Write 2 examples. Again, a similar question. What is a wind instrument? An instrument in which sound is generated by the vibration of an air column. So here, a musical instrument in which the sound is produced or generated, you can say, by the vibration of an air column. And you have to write 2 examples. Say, I will write the examples. We have been discussing many examples. We will write the examples as recorder and say clarinet. Then the next one, what is a percussion instrument? Write 2 examples. What are percussion instruments? Musical instruments that produce sound by the vibration of a membrane or a metal plate or rod. So here, musical instrument that produces sound by the vibration of a membrane or a metal rod or a metal plate. So those are the percussion instruments. Write 2 examples. Again, we have been discussing many different examples. What can you write? You can talk about the drum, the rabana, then any other instrument like xylophone, the cymbal, or even the thal. So we can write any 2 of the examples. I will write the examples here as rabana and say the thal, or you can write it as thalama, thalam, all refer to the same instrument. I will move on to the next one. Extra question 17. Write the 3 characteristics of sound. You know the 3 characteristics. What are they? Pitch, loudness, and quality of sound. So here, pitch, loudness and quality of sound. Next one. Write the three factors that affect the frequency of the sound generated by string instruments and how. So here you have to write the factors and you have to say how they affect the frequency. What is the first factor? Tension of the string. So first one, tension of the string. How does this affect the frequency? When tension increases, frequency increases. So tension increases, the frequency, I'll use the symbol F, increases. So here for frequency, I'll be using its symbol F. So here we have to write the three factors. What is the second factor? Length of the string. Length of the string. How does this affect the frequency? When length increases, frequency decreases. So here length increases, frequency decreases. And what is the third one? The mass of a unit length of the string. So that is the third factor. Third one, mass of unit length of the string. How does this affect the frequency? When the mass increases, frequency decreases. So here I will say mass increases, frequency decreases. In order to increase the frequency of sound, you have to increase the tension, you have to decrease the length of the string, and also you have to use a thin string, or you have to reduce the thickness so that the mass of the unit length will decrease. If you want to reduce the frequency, then we have to decrease the tension, make a long string or use a longer string, increase the length of the string, and also we have to use a thick string or a string with a higher mass per unit length. Then the frequency will decrease. With that, I will move on to the next question. Extra question 18. Write the factor that affects the frequency of the sound generated by wind instruments. How? You all know in wind instruments, sound is produced by the vibration of an air column. And by closing and opening the holes in the instrument, you can change the length of the air column. So, the factor that affects the frequency is the length of the air column. So, that is the first answer. Length of the air column. And how? When the length increases, the frequency decreases. And when the length decreases, the frequency increases. That is what we have to write here. Length of the air column increases, then frequency decreases. You can also say when the length of the air column decreases, the frequency will increase. Or else, if you write one answer, this is enough. The next question. What is an echo? What is an echo? When sound is generated, it travels through air. If there is an obstacle, it gets reflected back. But when the distance between the person and the obstacle is more than 11 meters, then you will hear the reflected sound and the initial sound that were produced. That is known as echo. So here, what is an echo? We can say hearing the produced sound and the sound reflected by an obstacle is known as echo. With that, I will move on to the next question. Extra question 90. Briefly explain ultrasound and ultrasound waves. What is ultrasound? Sound that has a frequency above 20,000 Hertz. So, ultrasound, sound with frequency above 20,000 Hertz. And ultrasound waves. What are they? Sound waves that have a frequency above 20,000 Hertz. So here we can say sound waves with frequency above 20,000 Hertz. The next one. The characteristics of electromagnetic waves vary significantly in various frequency ranges. What is the name given to the various frequency ranges identified by such characteristics? What is that arrangement called? The electromagnetic spectrum. So here the answer is electromagnetic spectrum. Then I will move on to the next question. Extra question 20. What is the electromagnetic wave that has extremely high frequency and possesses high amount of energy? You all can remember, students, when you go from the lowest frequency to the highest frequency, the energy of the waves also increase. We start with the radio waves, then we have the microwaves. After the microwaves, there is the infrared rays, then the visible region, after that the ultraviolet region, after ultraviolet, there is X-rays, and finally we have gamma rays. Gamma rays have the highest frequency and highest energy. So what is the electromagnetic wave that has extremely high frequency and possesses high amount of energy? That is gamma rays. So the answer here is gamma rays. Okay, students. So with that, I have come to the end of the discussion on extra questions and the end of discussion of this lesson, waves and their applications. So as I always say, listen to the discussion, read your textbook, again listen to the discussion, clear all your doubts, and then practice as many questions as possible so that you will be very competent to answer any type of question.